Welcome back. This is the lecture Viva La Evolution. Then this is part two. So this is the scenario we were considering, and we were writing the information in this table called the two-player payoff matrix. Um, we are able to read out of here the values of payoff that one individual may obtain. Um, this is specified here in pairs, where the first entry goes for individual 1, the second entry goes for individual 2. So given this type of information, what is natural is to address, well, which is the dominant strategy? Where here the strategy being um, this size of the body, either small or large. We had mentioned this. The size of the body is a trait that is visible, right? So we're also considering this as a phenotype, and so that size or that phenotype is what is considered a strategy. And while an individual doesn't make the choice whether or not which body size the individual will have, when you look at this scenario on the time scale of an evolutionary process, as an evolutionary biological process, then individuals on the population undergo um, this type of uh, the individuals may basically uh, come up with one phenotype or the other one due to random chance. Um, and so it's in that sense that evolutionary speaking, there is some type of game, if you will, and it's in that sense that there are strategies here, the phenotypes being considered strategies, to the extent that individuals with a particular phenotype may have a return when it comes to energy. So um, you will read more about the interpretation of this in some of the references, but what we address now is which of these two phenotypes will dominate in the population, meaning which will be, you know, dominance would be that most individuals will carry that phenotype. Uh, and that's a dominance in that sense. So what we're going to do is that using the same information in this table, we're going to address this question about which strategy, small or large, dominates. So um, if beetle 2 has a large phenotype, so we're going to assume that beetle 2 is locked in into the phenotype of having a body size large, then we're then considering, okay, what happens to beetle 1, assuming that beetle 2 is always locked in into this. So beetle 1, if beetle 1 has a small body size, then an interaction with beetle 2 will result in 1/8, meaning that beetle 1 gets a payoff of 1 versus while beetle 2 gets a payoff of 8. But if beetle 1 has a large body size, that ends up on a payoff of 3 and 3, where beetle 1 gets a payoff of 3. So the strategy that gives the the largest payoff to beetle 1 would be large. So if beetle 1 could choose what phenotype to carry, then based on this analysis of there are two scenarios for beetle 1, because beetle 2 is locked in into this body size, and out of these two scenarios, one gives a payoff of 1, the other one gives a payoff of 3. The one that gives the largest payoff is large. Okay, so the strategy that gives beetle 1 the largest payoff would be the strategy we're calling large. Now let's assume that beetle 2 is locked in with the small phenotype, okay, the phenotype of small body size. And so if that is the case, we do the same type of thing. Beetle 1, if beetle 1 has small size, then the scenario is this, 5 units for each. But if beetle 1 has a large size, then the outcome is 8-1. So beetle 1 would get 8 units. So the strategy large yields beetle 1 the largest payoff. So let's assume now that it's not beetle 2 but beetle 1 which is locked in. Let's assume that beetle 1 has the phenotype of small body size. And let's do the same we did, but now for doing this for beetle 2. So if is known or is given that beetle 1 has a small body size, then beetle 2 has one of two options. One would be to have a phenotype small. In such case, beetle 2 would get a payoff of 5. But if beetle 2 has a large body size, an interaction with beetle 1 would give beetle 2 a payoff of 8. So beetle 2 obtains the greatest payoff whenever beetle 2 has a large body size. And if we do something similar, assuming that beetle 1 is locked in with the body size of large, then what we find is that beetle 2 would get 1 by having a small size, or 3 units by having a large size. Then uh, in such case, beetle 2 gets a maximum payoff whenever beetle 2 has a large body size. So to the question of which strategy is considered dominant, we would say that, so to answer this question, uh, we have uh, we have done an analysis for each individual 1 by making an assumption on individual 2, and we have reviewed what are the possible outcomes for individual 1, the possible payoffs. And we've done the same for individual 2. We make assumptions on individual 1, and we have analyzed or reviewed what are the possible payoffs for that individual. And in all cases, we obtained that it was in the best interest of individuals 1 and 2 to carry the phenotype of large body size. So we would say that as a strategy, that phenotype would be dominant. That this translates into having, according to these values on the payoffs, this translates basically into that time scale that we were mentioning on this as an evolutionary process. If these are the values of payoffs uh, in these interactions in these food competitions, then we would expect that pretty soon most of the population would end up carrying the phenotype of large body size. That's what it means for a strategy to be dominant. It means that if you count how many individuals, and better yet, the proportion of individuals in the population with this particular strategy, then that proportion will get larger and larger and larger, and that is the notion of dominating as a strategy.